So we're going to take a few minutes to just go through the various structures of the heart using the model that we have here. Heart is a four-chambered pump containing two atria, two ventricles. The right atria and right ventricle will pump to the pulmonary circulation in the lungs. The left atria and left ventricle will pump out to systemic circulation throughout the remainder of the body. When we take a look at the heart, we have the two ventricles inferiorly. The atria are located superiorly. We can open the atria in this model. And on the inside, what we're going to notice is that the anterior surface is fairly roughened with what we call pectinate muscle. And the posterior surface is much more smooth. This is the portion that's actually anchored into the posterior aspect of the mediastinum, so we're not going to get a lot of contraction from that area. The separation between the two is through this cristae terminalis, as it's referred to. When we take this off, we can see on the inside here, between the right atria and the left atria, we have the interatrial septum, and that's going to contain the fossa ovalis, the remnants of the foramen ovale, where heart would be bypassed from the right side to the left side during embryological development. If that area does not close over completely, then you end up with a patent foramen ovale, which is one of the more common septal defects, resulting in essentially a hole in the heart. Opening up the right ventricle now. And what we'll notice is, once again, that we have this roughened surface. This time it's the entire way through the ventricle, because unlike the atria, the ventricle is basically freely floating from the posterior aspect, so the entire thing is filled with what we call this trabeculae carnae, which allows maximum squeezing to be able to push the blood out. Blood enters the ventricle from the right atria through the atrioventricular or tricuspid valve. And we can see here that we have papillary muscles anchored into the anterior wall, which would be attached to these chordae tendineae, which in effect are also attached into the valvular cusps. So when the ventricles contract and the cusps push backwards, contraction will keep them from pushing too far and will seal off the atrioventricular valve. From here, when the ventricle contracts, the blood is pushed up and will exit through the semilunar pulmonary valve, which is being shown as being shut in this particular view, and will then enter the pulmonary trunk, which will then go through the pulmonary arteries into the lungs for reoxygenation. So in this case, we do have arterial blood, or we do have arteries, but this will be deoxygenated blood as it needs to go to the pulmonary circuit to be able to drop off carbon dioxide and receive a new supply of blood. From there, it will return through the pulmonary veins into the left atria, and on the inside, we can see 4 sets of veins returning in, the 2 left pulmonary veins and the 2 right pulmonary veins. From here, when the left atria contracts, the blood will be forced down through the bicuspid or mitral valve into the left ventricle. So we can see here the wall thickness of the left ventricle is much thicker than what we see in the right ventricle, and this is because the left ventricle is responsible for pumping blood out to the systemic circulation, whereas the right just has to pump to pulmonary circulation, and so consequently it's not under the same amount of pressure, it doesn't need the same amount of force. Take a look to the side here. You can also see right off of the aorta, which is where the blood is pumped to after the left ventricle contracts. This is how it'll go up. We'll return to the rest of the body. But we can see in this area, just coming off the aorta is our left coronary artery, and that's going to supply the blood down in between the left and right ventricles through our left anterior descending artery. And on the other side, taken away here, but if we put the atria back in place, we can see in the underside that we have the right coronary artery traveling around and towards the back. That will deliver blood into the posterior interventricular artery. Delivering blood back would be the middle cardiac vein. From the front, we have the great cardiac vein accompanying the left anterior descending. And in both situations, they will drain into the coronary sinus, which wraps around posteriorly back into the right atria. And this gives a very rough idea of the blood supply through the heart.